Hello everyone and welcome to Module 3 Video 6 Using Remix for Smart Contract Deployment. My name is Sanchit and I'll be guiding you today through the process of using Remix, an essential tool for Ethereum smart contract development. We'll cover everything from setting up your environment to deploying and developing and interacting with the smart contracts. First, let's go over the key topics we'll cover in this video. We'll start with an introduction to Remix, then move on to setting up your development environment. After that, we'll dive into writing and compiling smart contracts, deploying them and interacting with them. We'll also explore using the Remix debugger, writing and running tests. And finally, deploying to a testnet. By the end of this video, you should have a solid understanding how to leverage Remix for efficient and effective smart contract developments. Remix is an open source web and desktop integrated development environment or IDE specifically designed for Ethereum smart contract development. It offers a rich set of tools for writing, testing, and deploying smart contracts. You can think of Remix as a Swiss Army knife for blockchain developers, offering various tools needed for developing smart contracts all in one place. With its user-friendly interface, Remix makes it easy for both beginners and experienced developers to build decentralized application or dApps on the Ethereum blockchain. To get started with Remix, you can access it through a web browser or download the desktop application. No installation is required for the web version. Simply open your browser and navigate to Remix IDE. Using the web version is like accessing a fully equipped online workspace without need of installing any software. You can also customize your workspace by installing various plugins available in Remix to suit your development needs. Now let's write and compile a smart contract. First, open the Remix editor, create a new file in the contracts directory and name it messagecontract.sol. Write your smart contract code in the file. For example, I'll be showing you our smart contract code we will be using. And once you have written the code, use the built-in Solidity compiler in Remix to compile it. This process is similar to writing code in an online IDE and compiling it to check for errors and generating executable files. Now I'll show you the code. We have seen this code several times in the last few videos. This is the basic Solidity code we will be using to get message and set message. All these lines are already known to you, so let's move forward. After writing and compiling your contract, it's time to deploy it. Here are the steps. First, select the compile contract from the down drop menu. Choose your deployment environment such as JavaScript VM or injected Web3. Click Deploy to publish your contract. Deploying your smart contract involves making it accessible for interactions. Deploying in Remix is like publishing a web application to a server where it becomes available to users. By selecting JavaScript VM, you can run the contract in local virtual machine, which is great for testing. For more realistic scenarios, use injected Web3 to deploy on a network connected through MetaMask. Once your contract is deployed, you can interact with it directly in the Remix interface. The deployed contract instance will appear, allowing you to call functions like setMessage and getMessage. This interaction helps you manage the contract state and functionality. You can firstly call the setMessage function to update the message, then you can call the getMessage function to retrieve the current message, and then you can view the current state of the contracts variable and all the results of previously called functions. This feature makes it easy to test and verify the behavior of your smart contracts directly within Remix. Remix also offers a powerful debugging tool. Open the debugger plugin, select a transaction to debug and use the debugger controls to set through the transaction and inspect variables. This is similar to using a debugger tool in an IDE to step through code and find bugs, providing insight into your smart contract's behavior. The Remix debugger helps identify where things might be going wrong and allows you to inspect the state at which steps of transaction are gone wrong. Testing is crucial for ensuring your smart contracts work as expected. Open the Solidity Unit Testing plugin in Remix, write your test script in the tests directory, and run the test using the plugin. For example, you can write a JavaScript test for your message contract. Here is the example. Here, the first line of the code imports the message contract artifact. The second line defines the test suite for message contract. The third line defines an individual test case. The fourth line gets the deployed instance of the contract. The fifth line calls the setMessage function on the contract, and the sixth line calls the getMessage function to retrieve the message. The next line asserts that the message was set correctly. Running these tests help verify that each function in your contract performs correctly. You must do this so that you can ensure that your code is running well and it is running the test. Before deploying your smart contract to the main Ethereum network, it's a good idea to deploy it on a testnet like Ropsten. Here are the steps to deploy it on Ropsten. First, connect the MetaMask to Remix and select Injected Web3 in the Deploy and Run Transactions plugin. Ensure MetaMask is connected to the desired testnet such as Ropsten. Deploy your contract using the Deploy and Run Transactions plugin. This process is similar to releasing a beta version of software for external testing and feedback. Deploying to a testnet allows you to conduct through testing in a realistic environment before going live on the mainnet. In conclusion, we have covered the essential aspect of using Remix for smart contract development. We discussed setting up your environment, writing and compiling contracts, deploying and interacting with them using the debugger, running tests, and deploying to a testnet. Remix is a versatile tool that can significantly streamline your development workflow, making it easier to create robust and reliable smart contracts. To reinforce what you have learned, try these interactive exercises. First, access the Remix IDE, write and deploy a smart contract, interact with the deployed contract, use the debugger to step through a transaction and inspect variables. Write and run tests for your smart contract. Deploy your contract to a public testnet. These hands-on activity will help solidify your understanding of using Remix for smart contract development. Thank you for watching this video. I hope this video provided you with a clear and comprehensive understanding of using Remix for your Ethereum smart contract project. In the last few videos, we saw how to write smart contracts in JS to run and test them. We also studied about MetaMask and how to include it in projects. We saw how deploying the contract and testing it is important and how to do that. If you have any doubts, please feel free to reach out. Thank you.